Alright, this set of notes is actually all information that you already know. We're just putting it together. So what I would suggest is attempting each of these problems on your own, pausing the video, and then playing it just to check and make sure you have everything correct. Also, please use pencil so that way you can erase. Alright, so we're working with the absolute value function. So remember, the parent function for absolute value is f of x equals the absolute value of x. And you'll notice with each of these graphs, the parent function is already graphed. So you should know how to graph that parent function, and you know a few of the points. So you know -1, y is 1, because the absolute value of -1 is 1. When x is 0, y is 0. When x is 1, y is 1. So that's these points right here. Okay, so remember, absolute value is going to be your distance away from 0. So how far away from 0 the number is. Alright, when I go to graph these, the graph of g sub 1 of x equals the absolute value of x plus 6. And we're going to talk about how that's going to look on the graph. So when I have a plus 6 and it's outside of the absolute value function, remember, if something is outside, that's going to be a vertical translation. And if it's a plus 6, that means it's going up 6. So your transformations, you're going to use those a lot. Basically throughout the entire year, you're going to use them for each of the parent functions, each unit, and then you're going to use it again in pre-cal. So if you don't have transformations down, that's something that you're going to want to make sure you get. So we're going to translate up 6. So for each of these points, we're going to move it up 6. Oh, and I didn't realize this was going by 2, so technically my points were right there and right there. Okay, so we're going up 6. So our new vertex, instead of at 0, 0, it's at 0, 6. Alright, and then we're going to move everything else up 6. So we now have a graph that looks like this. Alright, and in green I'm going to do the next part. So we've got g sub 2 of x equals the absolute value of x minus 4. Again, this minus 4 is outside of those absolute value signs, so it's outside of the function. So it's still going to be a vertical shift. Since it's minus 4, it's going to be shifted down 4. So I can just take each of these points and shift them down 4. So my point at 0, 0 moves to 0, negative 4. My point at 1, 1 would move down to 1, negative 3. And -1, negative 3. And so on. So we get a graph that looks like this. As close as I can get. So it's that parent function absolute value shifted down 4. Okay, for part B, again we're looking at our absolute value parent function. So we've got points at 0, 0, 1, 1, negative 1, negative 1, 2, 2, negative 2, 2. Alright, so on this first part, we've got g sub 1 of x equals absolute value of x minus 3. Notice that minus 3 is inside the absolute value signs, so that's inside the function. So that's going to be a horizontal shift. Also remember, inside is inverse, so that means it's the opposite of what you would expect to happen. You would think that minus 3 would shift left 3, but really it's going to be translated right 3. So I'm going to take each of these points and move them to the right 3. So instead of 0, 0, we're going to be shifted over 3 to 3, 0. instead of 2, 2, we're going to be shifted over 3 to 5, 2. Instead of this point at negative 2, 2, we'll be shifted over to 1, 2. All right. Now we'll do the next one. That one in orange. So we've got the absolute value of x plus 5, and that plus 5 is inside the function. So again, it's horizontal, inside is inverse, so plus 5 is actually going to shift left 5. So instead of 0, 0, we'll be at negative 5, 0. It's taking that vertex, moving it to the left 5. This point at 2, 2 is going to shift to the left 5. So we'll be at negative 3, 2. And the point at negative 2, 2, shift that left 5. We'll be at negative 5, 2. Sorry, negative 7, 2. And these are also things that you can check on Desmos as well. All right.